Alright, so this time I'm doing problem 12 from chapter 7. And the problem says, Tarzan in one tree sights Jane in another tree. He grabs the end of a vine with a length of 20 meters that makes an angle of 35 degrees with the vertical. He steps off his tree limb and swings down and then up to Jane's open arms. When he arrives, his vine makes an angle of 30 degrees with the vertical. Determine whether he gives her a tender embrace or knocks her off her limb by calculating Tarzan's speed just before he reaches Jane. Ignore air resistance and the mass of the vine. So, if we were to draw a picture, we've got a tree, we've got two trees, and on one limb we have Tarzan, and over here we have Jane. And it's not a great drawing, but it kind of gets the point. Tarzan grabs the vine, he's going to swing down and up to where Jane is. And it gives us the initial angles and the length of the vine. So we know that the length of the vine is equal to 20 meters. We know that the initial angle from vertical is 45 degrees, and that the second angle is 30 degrees. And then it wants us to find the velocity that Tarzan has when he reaches the vine. So, to do that, we know that Tarzan's going to have he's going to we have an equation, kind of the equation for the conservation of energy. So we know that mass times gravity times the height, first height, plus 1/2 mass times velocity squared, first velocity, is going to be equal to mass times gravity times the second height plus 1/2 mass times the second velocity squared. So we know that initially when Tarzan's over here, he has no velocity, he's at rest, and so this term goes to 0. And we can then simplify and kind of solve for the second velocity. So we can rewrite this equation as 1/2 mass times the velocity 2 squared is going to be equal to mass times the gravity times height 2 minus mass times gravity times height 1. We can then work some more with the equations. 1/2 mass, velocity 2. Both of the masses and gravity are going to be the same on this equation. So we can pull those out. Mass times gravity is going to be times height 2 minus height 1. And we can then also isolate for the final velocity. So we know that final velocity is going to be equal to 2 times mass times gravity times the change in height divided by the mass. And so those will cancel, and all of that is square rooted. So the main thing we need to find is the difference in heights. But we know that height 2 minus height 1, using geometry, is going to be equal to the length of the vine times cosine of 30 degrees minus cosine 45 degrees. because it's going to be height 2. So length times cosine of 30 will give us height 2. Length times cosine of 45 will give us height 1. And so in order to be equal to that, it has to be cosine 30 minus cosine 45. We can then take all of this and substitute it down in here for that. So we can then rewrite that as, that's really terrible too. So the second velocity is going to be equal to the square root of 2 times gravity times length times cosine of 30 degrees minus cosine of 45 degrees. All of that is under the square root sign. So then you plug in the rest of your numbers. So 2 times 9.8 times 20. Gravity is 9.81. We're just using 9.8 because that's how I did the math. 20 is the length of the bind times cosine of 30 minus cosine of 45. And then when you do the math, that comes out to a final velocity of 7.89 meters per second. And so we can safely assume that since he's moving this fast, when he reaches Jane, he's gonna knock her off the limb. And it's probably not gonna be very romantic.